So in this video we're going to find the variance of the beta distribution. Now the beta distribution, that's written like as beta a comma b with parameters a and b which are both greater than 0, and the support of the random variable x, that's always between 0 and 1. And the PDF, so the PDF, which is f of x given our parameters, which is a and b, that is written as a combination of gamma functions and some polynomials. So it's gamma of a plus b divided by gamma of a times gamma of b, and then a polynomial which is x to the a minus 1 times x minus 1 to the b minus 1. That's its PDF. So we put these in separate little boxes. We're going to need these to work out our variance. Now in the previous video we found the mean of this beta distribution, so if you check the link below you'll see how that was done. And the mean, which is e of x, that was a over a plus b. That's how that was calculated as. So that's another result we're going to need. Okay, so now the variance. How are we going to calculate the variance? Now we've got the expectation of x, i.e. the mean. So there is a formula to calculate the variance, and that is variance of x equals e of x squared, so the second moment, and we subtract the mean squared. So the mean squared. So that's a result we can use to calculate our variance. So we've got the mean, so this here is the mean. So if we just square that, that will give us our mu squared. But now we need to find the second moment, e of x squared. How are we going to do that? Well, we can use the same method as we did in the previous video to find the expectation of x. So what we did was e of x, that was calculated by integrating over the support, which is 0 to 1, which is the range of our beta distribution. And then we multiply that by x times this PDF. So we had gamma a plus b divided by gamma a times gamma b, and then x to the a minus 1, x minus 1 to the b minus 1, and all with the range of dx. So that was e of x, but we need expectation of x squared. So what we can do is we just write an x squared term there and an x squared term there. That will set us on our way. The result of this integral here will give us our e of x squared. So let's go into that. Let's do that. So x squared times this gamma fraction here, and then these polynomials. So these two gamma functions here, this fraction, there's no variable x in there, so this we can bring outside of the integral. And then the x squared and the x to a minus 1, we can combine those two. This one here we can do nothing with. So let's set that up. So integral from 0 to 1. Let's write this gamma outside of our integral. So now we've got gamma a plus b over gamma a times gamma b, and then x to the a minus 1. And with this x squared term here, we need to add 2. And then here we've got x minus 1 to the b minus 1. And with regards to x. Okay, now this is fine, this is constant multiple in regards of our parameters, but we've got this integral here. Now we're not going to be able to do that with normal integration techniques, but there is an identity which we can use, and we worked out in the previous video the result of, if I use what's inside this integral here, from 0 to 1, x to the a minus 1 x minus 1, let's write that as minus 1, to the b minus 1 dx. The result of this will give us the reciprocal of this gamma fraction. So that will give us gamma A, gamma B, divided by gamma A plus B. So we know that is an identity. But here we've got A minus 1 plus 2 and B minus 1. So this is not exactly the same. So I can put a bracket round that and a bracket round that. So here, what we want in here is A minus 1 and whatever else is in that indice there. Well, we've got A minus 1 plus 2. So if we was to put a plus 2 along that bracket there, we would now have to write a plus 2 in our gamma result. So now we'd need A plus 2 plus B, just to change that. And here we would need a plus 2 in there as well. So that would be the result of our integration here. So no integration to do, we could just use an identity and then we could substitute that in there. So what I'm going to do now is take this off the board and write our result inside here. So this is going to go in there for the result of our integral. And this gamma function here is going to stay. Okay. Okay, so that's the result of the integration by doing our substitution in there. Okay, so now we've got this complicated looking gamma multiplication and fractions going on. So what can we do with that? Well, first of all, I've got gamma B, they're multiplied, so I can just cancel those out, that's fine. But now I've got this gamma A plus 2 plus B, gamma A plus 2, gamma A plus B. Nothing much I can do there at the moment. So I need to call on another identity. So I know that gamma of A plus 1, that as this, by the fact that this is a factorial function, I can write that as A gamma A. That's how I can write that. So here I've got gamma A plus 2. So therefore gamma A plus 2, I can write that as A plus 1 times A times gamma of A. So that's what I can write for this one. Now here I've got gamma of A plus 2 plus B, which I could rewrite just to make it easier to see, A plus B plus 2. So in which case I could write this as A plus B plus 2 times A plus B plus 1 and A plus B. So that's how I could rewrite this one. So I'm going to rewrite this now using this identity. So now all in one fraction, I've got gamma A plus B divided by gamma A. So that takes care of all of this. Now gamma A plus 2, I'm going to write like this. So now I've got A plus 1 times A times gamma of A. So that takes care of this one. That's cancelled out, that's fine. Now this one, I'm going to write something similar, but instead of A plus 1, I'll write A plus B plus 1, and A I'll write as A plus B. And then here I've got gamma A plus B for that one. Okay, so rewriting this, I will now have gamma of A plus B, and then I will multiply that by A plus B and A plus B plus 1. So that would take care of that. So now I've got some cancellations which I can now do. So now I've got gamma A, fantastic, that will cancel. And gamma A plus B and gamma A plus B, that will also cancel. So now what I've got so far now with E of x squared, so I can now write E of x squared, that equals A times A plus 1 divided by A plus B times A plus B plus 1. Okay, So that's what we got so far. So we've got our e of x squared. So now what we need to do is clear some space on the board and start to calculate our variance from these results here. Okay. Okay, so now we're into this one here now. This is important now. So we've calculated our e of x squared. We know what our mean is, i.e. our e of x. So now we need to set this one up. So now v of x, so that's our variance. That equals e of x squared, which we've calculated, which is a plus 1 over a plus b times a plus b plus 1. Okay, so that takes care of that. And then we need to subtract our mean squared. So that's subtract a squared over a plus b squared. Okay, that's what we need to do there. So what can we do now? Well, we need to do the algebra on this to try and simplify this up a little bit. We've got a plus b plus 1 and a plus b squared. So we need to get a common denominator first. So we'll write this now as one big fraction. So a plus b squared, I'll write that first. Hence I've got an a plus b here. And then multiply that by a plus b plus 1. So now, if I've got a common denominator, I need to try and get this the same with this one. So if I multiply top and bottom by a plus b, that's how I will get that. And then multiply this by a plus b. So now I'm going a plus 1, a plus b. And then this one here, a plus b squared. I now need to multiply top and bottom of this by this quantity here. So now I've got a squared times a plus b plus 1. So that's still the same as what we got here. So now let's just try and see if we can do something with this. Let's try expanding it all out and see where that takes us. So a times a plus 1, that will give me a squared plus a. And then multiply that by a plus b. And then distribute this a squared inside here. So now I've got a cubed plus a squared b plus a squared. That would be that. And then my denominator stays as it is. So a plus b squared, a plus b plus 1. Okay, now let's distribute again. So now we've got a squared times a, so that's a cubed, a squared times b, so add a squared b, and now distribute this a. So now we can add a squared, and a times b, so that's add ab. And now subtract all of these ones. So now minus, bearing in mind now, we need a bracket inside of this. That's what we need, because this is all of one term, all subtracted. So now we've got minus a cubed minus a squared b minus a squared. And then divide that by a plus b squared times a plus b plus 1. Okay, now that's quite a mouthful there to work out what that is. So let's simplify it up. So start with the cube terms. We've got a cubed minus an a cubed. So they're gone. We've got a squared minus a squared. So that's gone. And now we've got a squared b minus a squared b. That one is also gone. So all we've got left now is this one here, which is a positive. So now our variance of x, so the variance of the beta distribution, is a times b over a plus b squared, a plus b plus 1. And there's not much point in multiplying that out. That looks just simple as it is. As these two will be constants, you'll end up with a squared term, and then 2 constants plus 1. That will give us our result. So for example, if a, let's calculate this at a equals 2, b equals 3, this would evaluate to 2 times 3, which is 6, and then a plus b is 5, squared is 25, and then multiply that by 5 plus 1, which is 6. So then that will cancel out. So then our variance would equal 1 over 25, 0.04. Okay, so now we've got our variance. So beta of 2, 3, that would lead us to a mean of a over a plus b, so that's 2 over 2 plus 3, which is 2/5, and a variance which would be sigma squared, which would equal 1 over 25. Okay, that's our beta distribution.